Hello and welcome to KnowledgeBank.pro. Today we're talking about price value mix calculation, and I cannot tell you how many people somehow found me on LinkedIn, left comments in the YouTube section, left comments in my blog, asking for the follow-up, asking a bunch of questions on how the thing works. So what I decided to do is a series of videos that will cover price value mix in detail. So I'm going to call this the definitive guide to price value mix, because unlike most other articles that you will find on YouTube or online, I'm not just going to tell you how the calculation works. We're going to talk about the basics of PVM. We're going to talk about the components, and I will explain why it works as well as how it works, so that you guys will actually understand the math behind this method, what it's trying to achieve, and why it's such a popular tool in a lot of finance departments. Not sure how long this video will turn out to be, because this is more of a lecture. What I'm probably going to do is break this particular video, this specific one, and just make it a theory. So let's cover everything theoretical. I'm not going to get too deep into Power BI. I'm not going to get too much into the implementation. Once I'm done with the theory and you guys have a good understanding of the concept, then you could look forward to a follow-up video with the actual PVM model in Power BI and maybe a bunch of other surprises. We'll see how things work out. So as the tool to help me make my points, I put together this spreadsheet. So let me explain to you what's going on so that you're not confused as I'm playing with the numbers here and frame up the concepts. So what's happening here, and I want to distill it down to a very, very simple data set. And turns out just having two products in our sales portfolio is enough to make the point. So what we have here is we have two products, A and B. Then we're going to be comparing our performance of last year. So what we have is for both of the products, we have their price, $1 for product A and $2 for product B. We have the volumes, what we sold last year. We just sold one of each. And if I know the price and the volume, I can obviously calculate the revenue. Then here we have mix. I will spend a little bit more time on this in just a little bit. And then what I've done is I have another section here in green where I will be playing with this year numbers. So what we're going to do is we're going to create a bunch of different scenarios in this year numbers, compare them to last year, and as we increase either the price or the volume or change the mix of our products, this will create what we call deltas or variances, right? So there's going to be some sort of variance in price if the price goes up. There's going to be some sort of variance in delta in volume if volume amounts will change, revenue, and mix. At the end, what we have is, and that's the ultimate goal of our calculation, is to create with the price value mix breakdown that takes our overall variance of this year to last year and breaks it down by volume, mix, and price components, not only as a total, but also for individual products in our product portfolio. So I think everybody has a pretty good idea of what volume and price components are, although I argue that what you think the volume component is not really what it actually is. So we'll talk about this in a little bit. But I think you're probably comfortable with volume and price. Let's talk a little bit about mix. What does mix mean? Well, let's take a look at last year's mix. So we had 1 unit of A and 1 unit of B sold last year. So in total, we sold 2. So in order for us to understand what the mix is, we just need to understand the share in the total unit portfolio of each product. So when we have 1 and 1, 1 plus 1 is 2, our share of each product or mix is 50-50. So here, the more products you have, the more different breakouts you would have, but they all have to total to 100. So before I get into the details of the calculation, let me frame up 3 different scenarios of how our this year situation changes relative to last year's situation, right? So we will create a scenario for, okay, the price is driving the change, the volume is driving the change, or the mix is driving the change. Make sure that you guys are comfortable with those scenarios and analyze the output of the calculation. And once you understand the 3 scenarios that we're trying to test, we're going to take a look at the calculation and I'll explain to you how the math actually works. So let's do the easy one first. So as we said before, in the prior year, last year, the prices of our products were 1 and 2. So if I were to test the price component of the calculation, what I would need to do is I would need to keep everything constant and the only thing that I should do is change my price. So here's my mix last year, 50-50. Here's my mix this year, 50-50. I'm going to change one of these components here where only the revenue will change. The price rather will change. So let's say I'm going to come to product A and say in this year, my product actually price was $2. So now let's verify if our assumptions were correct. We can see that price portion of the deltas has changed. We can see that the volumes did not change and mix didn't change. So the only thing that has changed is our price. Therefore, what we should expect is in our price, value, and mix columns, only the price columns should change, and the total of the variance should be total to the overall variance year over year. And that's exactly what we see. We see that revenue changed is $1 here, and then our PVM, all of that $1 comes from price bucket, and moreover, we only adjusted the price for product A, so all of that variance sits in product A. Okay, now I have reset it to the original settings, and let's try to change our volume component. So what I'm gonna do is I'm gonna double volume for both of our products. So in this year, let's say we sold 2 of each. Let's see what that does. So now that I've entered 2 and 2 for volume this year, we see that my total units is 4, and the price, so the volume has changed. The price hasn't changed because price was not adjusted. We still have 1 and 2. And you can see that mix is still 50-50. So even though the overall number of units went up, the distribution of units by product stayed exactly the same. So if we look into our PVM component, we see that overall, we have 0 impact for price. We have 0 impact for mix because overall it didn't change. And then we have a $3 variance due to volume change. You also see that on individual level, we have little bit of mix in each product, and most of the change is in volume, but in our case, the mix increase for product A is canceled out by mix increase by product B, and overall we have 0 mix impact in this scenario. So now let's take a look at scenario number 3, where the total number of units did not change, but the mix has changed. And what I mean by that is we still have 2 units that we sold last year versus prior year. Our prices remain the same, but mix has changed dramatically, right? So we stopped selling product A in this year, and we picked up an extra unit of product B. So total stayed the same, 2, but now you see we went from 50-50 split to 0-100 split. And then as a result of this, what we see in total, so in total, our portfolio, the only thing that's changed is mix, right? So you see that all of that change went into the mix because volume didn't change and price didn't change. So the volume component is 0, price component is 0, and all of the variance in revenue, $1 here, went into the mix. But you could see that on individual level, we do have some mix and volume stuff going on. And we will talk about details of how this is happening a little bit later, but that's kind of what you want to see, right? So if in a volume, when our portfolio, everything else stayed exactly the same, and the only thing that's changed is mix, then in total, all of the variance will go to mix. If our portfolio stayed the same, and the only thing that's changed is price, all of that variance will go into price. If our portfolio stayed the same, and the only thing that's changed was number of units sold, then that variance will all go into the volume. So by this point, you should be a little bit confused as to why on individual level we always have a little bit of mix and volume every time we play with volume or mix variables, and that's okay. Let's give it a few more minutes and this will get cleared up. But hopefully you're starting to understand at the portfolio level, when we look at all of the units holistically, how that total breakdown comes up to match our overall revenue variance. So now is the hardest portion of this video, where I'm going to try to explain to you the guts and the mechanics of this calculation and the philosophy of how this approach works and what it's trying to accomplish. So the most important number in this whole entire spreadsheet is this red number here. So here, when we look at our performance from last year and we look at overall total revenue, which is 3. So total revenue was 3, we sold 2 units, then we can calculate what was the average price of the unit, and that is $1.5. Another way to think about it is we can simplify our portfolio and just say, hey, if my mix does not change, then I don't care about what products I sold. I just need to know how many units I've sold. I know what the average price is, and as long as mix stays the same, then I can exactly tell you what my revenue is, right? So as long as mix is the same, I sell exactly my distribution of products of high price and low price, price does not change, then I can calculate the average price per unit. You tell me how many units you've sold, I'm going to take that number of units, multiply it by average price, and I will know exactly what the revenue is. So that helps me understand what the revenue will be for the entire portfolio, for all units. Now let's take a look at this one product at a time. If I know that on average I make $1.5 per every unit in terms of revenue, then I can look at both of my products and say, hey, on average, when I sell a unit, I make 1.5. However, when I look specifically at unit A, what that does is every time I sell an extra unit, I lose 50 cents, right? Because that unit, if I sell more of unit A and amount of units that I sell stays the same, that my revenue will shrink because number of my average price will shrink, right? So basically, by me anchoring to this average price, I can then look into my units as good and bad. Good units are the ones where the price is higher than average. Every time I sell more of those at the expense of selling less of bad ones, my revenue will go up, even if I sell the same amount of units, right? And that's very important to understand. When you think about mix, think about we're going to sell the same amount of units, but we want to sell more of good units or more products than bad products. So a good product is the product where the price is higher than average, and the bad product is where the price is lower than average. Then we can quantify by how much. So how much is product B better than average? Well, by 50% in our case, right? So to know the contribution of each product relative to average, all I need to know is to know the difference between the product and the average price. So I can compute that. So for A, every time I sell more of A, I lose 50 cents. Every time I sell more of B, I gain 50 cents per unit sold. And now we can start talking about the actual guts of the calculation. So let's talk about price first and get that out of the way. So the way we calculate price is very simple. We take the volume of units this year, we multiply it by difference in price between this year and last year, and that will be exactly what the price component is. So let's test this quick. So here I changed the price from $2 that was last year to $3. How does the calculation then work? We're going to compute it one product at a time. So price didn't change here. So 1 times difference in price is going to be 0. So that's what we see here. We see 0. And then for the product B, I'm going to multiply the volume 1 times difference in price, which is 3 minus 2 is equal to 1. 1 times 1 is 1, and that's exactly what we see here, right? So the way we calculate price is we multiply the volume this year times the difference in price. So let's do this again. Now I'm going to do, let's say, 2 here instead of 1. So both of our products went up by 1. So the difference in price is 1. 1 times 1, volume is 1, difference in price is 1. We got 2 ones in here, so hopefully you guys can check. I just add them together. That's my total variance, $2, and that's the variance dollars that I get from this check table here. And now we talk about volume and mix. So we said before that the way we're thinking about volume and mix is going to be done in the context of average price. So the way we do the volume is we're saying if price and distribution mix stayed the same, that means that the average price would stay the same. So the way you calculate the volume effect is you're just multiplying number of units by average price. And that's exactly what you're going to see here. So let's go ahead and make some changes. We're going to make this number 2, and we're going to make this number, let's say 3. So what we would expect is the volume effect will be 2 times average price for product A and 3 times average price for product B. And that's exactly what we see, 1.5. So 2 times, sorry, I misspoke. So we need to multiply the difference in volume times average price, right? So we're doing volume effect. So we see that for product A, difference in volume is 1. So we take that 1, multiply by 1.5, and that's 1.5. Difference in volume. So volume this year minus volume last year is 2. 3 minus 1 is 2. We multiply 2 by average price, and that gets us 3. And now we've computed the volume impact of this change. And why are we doing this? Because we said that because we do have mix, right? So mix is the one that's gonna take care of change in distribution of units. So if we're just only gonna do the volume impact, we're gonna assume that all of the prices for units is the same. It's the average price. So we're just gonna multiply average price by difference in volume, and we'll know exactly what the volume impact was. So now you're saying, hey, Andre, why do you have a mix component in this calculation? So we said our overall variance is 5, right? So 4.5 of that is volume impact. Why do we have a 50 cent of mix impact? Well, that's easy. The reason we have a 50 cents impact is because our mix has changed. We went from 50-50 change in units to 40-60 change in units, right? So that has consequences. What consequence does it have? Well, we said that every time we sell more of product A, we lose quote unquote 50 cents because the product A is $1 or 50 cents less than average price. Every time we sell more of product B, B is a good product, so every time we sell more of it, we quote unquote gain 50 cents. Again, you gotta normalize it to the mixed distribution, but I just want to make it clear in your head so you can intuitively understand that good products, the more you sell them, they have negative cost relative to average price, right? So every time you sell more, then that just because you sold more of bad products, you're gonna then be dinged on the mix component. So how do you calculate the mix part? It's very simple. You're using the same column as before, change in volume, but you multiply the change in volume not by the average price, but rather by the cost of overselling it, right? So if I sell more of bad product, I'm gonna multiply 1 by the difference in price, by 50 cents, and that's what we have here. I sold more of good products, so extra 2. I'm gonna multiply it by difference between these two, that's 50 cents, that gives me $1. So selling more of bad products, product A, because it's less than average, gave me negative mix. Selling more of good products, product B, because it's higher than average, gave me positive mix. And overall, that mix splitting 40-60, which is intuitive, right? So we went from 50-50, bad and good. We're selling less good, less bad, and more good. So even though we sold more of it, so there is a little bit of negative mix, overall our mix is positive because the distribution stayed this way. Now let's go back to the scenario where I stopped selling product A and all of my volume shifted into product B. So overall, I have the same number of products I sold this year versus last year, it's 2. But now instead of selling product A, only thing I sold was product B. So our mix changed from 50-50 to 0 to 100. And let's see what it did to our PVM. Well, did our volume change for product A? Yes, we used to sell 1, now we're selling 0. Should we expect a volume component of PVM? Yes. So every time we sell a product, we make $1.5 on average. So we sold fewer, so that's gonna go into our volume, right? So our volume dropped by 1.5. But because we sold fewer of product A, we've gained something. What did we gain? Well, every time we sold product A, that costs us 50 cents because it's cheaper than our average. So that gain of not selling bad products anymore went into mix, right? So it says that our revenue difference between this year and last year is 1. So last year our revenue was 1 times 1. This year our revenue is 0 times 1. So our difference in revenue is -1, 0 minus 1. But the reason we have -1 is, yes, we did lose 1.5 from volume because that 1.5 average price time unit is going to give us volume, but we gain half a dollar on mix. So it did good things for our mix, and because we're selling more of the good products, we're leveraging this 50% variance. So let's take a look at our product B. So product B, we used to sell 1, now we're selling 2, and so we're realizing benefits twice. Number one is volume went up. Every time volume goes up, we're realizing $1.5 of revenue per unit sold. And we're also realizing the mix part, right? Which is the difference in units sold times the difference in prices. So we sold more of the good products. So we're going to benefit in both columns. We're going to benefit from volume and we're going to benefit from mix. How do we make it even better? Well, the only way to make it even better is to change our price to go even higher. Let's say now the price is 3. And now that gives us everything that we could possibly want. We sold more unit. We see this here. Unit volume went up. We improved our mix. So the percentage of good units went up from 50 to 100. And here you go. We gained 50%, 50 cents in mix. And moreover, our price went up by $1. And now we're going to take that price difference times the volume this year. And here goes $2. So overall, we have $3 improvements, which is we see here. And if we add up everything in the bottom row, 0 plus 1 plus 2 is 3. Why do we have 0 total? Well, because overall number of units stayed the same, right? So therefore, whatever we gained on bad units and whatever we lost on bad units and gained on good units in terms of the overall average price times volume, nothing's changed. We still sold the same amount of units, therefore the volume impact is 0. So let's summarize. Price component of PVM, units this year times difference in price. Volume components of PVM, change in units times average price. Mix components of PVM, change in units times product minus average price. You compute it for every product, you add it together, and you're going to get your overall portfolio in PVM buckets for all the products in your scenario. So in our case, we're comparing last year to this year. In your case, you might be doing forecast to actuals, budget to actuals, and so forth. The logic will stay exactly the same. You just have to decide where is the goal. So our goal is last year, or target, and where the actuals are. In our case, it's this year. So now that we are done with theory, there's a bunch of other things we would need to do before you're able to confidently implement it using Power BI. So what I will do is the following. As I'm working on all of the artifacts, the first thing I will do is I will make this Excel spreadsheet available on KnowledgeBank.pro. So you can go to KnowledgeBank.pro, register with your work address, log in into Teams, and go to File, to Channel, go to Files, and I will make a folder where this Excel document will be available. And while I'm working on the rest of the pieces for this class or for this lecture, this topic, I will only have that file available there. Once I finish up the build out of all of the artifacts necessary to put this course together, I will start publishing all of the files and all of the artifacts on my blog, as I usually do, so you could just download it from there and use it in your calculation. I realize that this is not an easy topic. I'm hoping that this video made the theory part of the calculation a little bit clearer for you guys. I will be doing a few more videos to follow up. They may come right after this one, or I might sprinkle a few other videos in between. We'll see how things work out. But I do hope that you found this video super informative and super interesting. Thank you so much for stopping by, and I hope to see you come back very soon. Bye.